Hello friends, welcome to next algorithm of data mining and machine learning, association rule mining. So basically this algorithm is coming under data mining, but it can be used to create a pattern like unsupervised learning in machine learning also. That's why we can consider this algorithm in the unsupervised machine learning. This is also called as the market basket analysis. You might have heard about this particular terminology, market basket analysis. How this can be done, that we are going to see. It's very interesting. Pattern identification algorithm is there, which we use regularly to create the patterns. Now, what is association rules? There are many ways to see the similarity between the items. These are the techniques that fall under the general umbrella of association. The outcome of this type of technique is, in simple terms, set of rules that can be understood as if this then that. Now, how if this and then that? See this particular picture. Now on this grocery store, it's written there, customers who bought this item, they also bought these items. It means that they are connected. So this is what we are giving as suggestions to the customers. Previously the one who bought this, they bought this also for maybe 80% time, 90% time, or 50% time, whatever. We are having a suggestion, so that the customer will get the suggestions, and based on that they can purchase more product from the respective store. This is what we call as market basket analysis. See the baskets that customer has filled from the market. So you can check it out. Analysis of it. If you see the analyze these baskets, you can check that there is a connection between the milk and bread. Milk and bread, milk and bread, milk and bread. So whenever particular customer has purchased the milk, he has purchased the bread also along with it. So we are analyzing these baskets of the customers. So what kind of machine learning is that? So these are the applications where we can make use of this product recommendation, like customer who bought this also bought this, bought that also bought this. So that's what we are going to have the recommendation in Amazon, music recommendation, like last FM artist recommendation, medical diagnosis, like with diabetes, really cool stuff, they are connected, or optimization of content, like magazine, websites or blogs. So that's what we are going to make use of it. So let's take example of the Amazon. That's what we call frequently bought together. Means if you buy this Raspberry Pi, so you can buy the case of it. Along with that, we can buy the charger of the Raspberry Pi also. Okay, so we can this very interesting example. Now the data set. So I want to find the connectivity, like if this then that. So we are having a data set, like imagine that 10,000 receipts sitting on your table. Each receipt represents the transaction with the item that were purchased. The transaction consists only the names of the items. The receipt is representation of a stuff that went into a customer's basket, and therefore it's called as market basket analysis. That is exactly what the grocery data set contains. It contains a receipt with each line representing one receipt and the item purchased. Each line is called as a transaction, and each column in a row represents an item. You can download the data set from the GitHub also. It's available there. You can download from MITU Skillologies repository, as well as from UCI machine learning repository also. Okay, so that data set okay, I'll show you data sets, how exactly they are formed and available here. So let's see the groceries data sets, very big data set available over here. With the help of that, we can do the find the predictions or generate the results from the association rules like this. So various customers have purchased these items. Like first customer has purchased these 4 items, second customer this 2, next is only 1, next this 4, next again this 4, then again next 5, then this 1, then again 5, like all. Check it out. So all their complete transactions are present over here, and these transactions are non-linear. Check this, all. A CSV file is present, more than 9834 transactions, 35 transactions are present in this. Okay, completely non-linear transactions with different kind of items purchased by the customers are available there. Okay, so how the concepts of this data set is generated. So we already discussed about the concept of items and item sets. We can represent our items in the item set as follows. Like I'm having the item set like this, I is equal to I1, 2, 3 till n. This is a set, so items are not duplicated. Therefore, a transaction is represented like this. Tn is a collection of different items, ij, ik, il, like till in. Okay, so many items are there, different items in transactions that we call, and the rule will be like this: I1 and I2. If you purchase I1 and I2, you most likely purchasing IK also. So these two items are connected with these two items, this one item. So this is what we call as a rule. And now let's consider if how this association can be shown. Okay, which can be read as: if user buys an item in the item set on the left hand side, then the user will likely to buy the item on the right hand side also. So human readable example like this: if you are purchasing coffee and sugar, so you are most likely purchasing milk also. Okay, the customer buys a coffee and sugar, then they are likely to buy milk also. So with this we can understand three important ratios: the support, confidence and the lift. They are associated here. Okay, so how they are used. See, once the association rules are formed, these rules can be characterized by three different parameters. We are not going to use any confusion matrix, mean squared error or any other way, because this is something different. It find the connectivity patterns in the data. And how can we characterize it? First is support. Support means the fraction of which our item set occurs in the data set. So one item is there which has occurred in the data set for certain amount of time. So what's the frequency of it in terms of percentages is called as support. Second is confidence. Confidence is the probability that a rule is correct for a new transaction with the item on the left. Means if I purchase this and purchase that, so how much percentage of time they are connected together in the data set. This is called as confidence. And the lift is the ratio by which the confidence of the rule exceeds the expected confidence. Basically the lift one indicate that the items on the left and right are independent of each other. So dependency of the left and right are connected with the help of a lift. Along with the lift, few more are there, but they are not much considered in characterization of it. So two most important factors which are considered here while characterization of the algorithm are support and the confidence. See, let's see the support. What do you mean by support? This says how popular an item set is as measured by the proportion of transaction in which the item set appears. See, the table is showing this one. For example, I am having some transactions. Transaction 1 is apple, beer, rice and chicken. So these apple, beer, rice are there. Now apple and pear, milk, beer, rice and chicken, and this is milk and pear, like all their transactions are recorded. So 8 transactions are there. In this 8 transaction, a particular item is occurred. How frequently? What's the percentage of occurrence of it? That is called as support. Let's calculate the support of apple. So apple is present in 8 transaction 4 number of times. So out of 8, 4 number of times present is called as 4 divided by 8. So 0.5 is the support of apple. Now support of 2 items is also possible. Now support of apple, beer and rice. So apple, beer and rice are coming together. How many number of time out of 8? So 2 number of time out of 8 apple, beer and rice are present in it. So 2 divided by 8, that is 25% is the support of apple, beer and rice. So frequency of item is identified with the help of how popularity of the item is identified by the support. Okay, so support can be calculated for single item or for combination of items also. Second is confidence. This is most important rule here, most important characteristic by which the association rules are formed and we are choosing it. This says how likely item Y is purchased when item X is purchased, expressed as X tends to Y. So this is measured by the proportion of transactions which with item X on which item Y also appears. See this now. The rule is like this: confidence of when I am purchasing apple, I am purchasing beer also. What's the confidence? So rule is this, formula is this: support of both divided by support of first. Support of both divided by support of first. This is what confidence is. Let's identify what is confidence. Now when I am purchasing apple, what is the possibility that I am purchasing beer also? Getting? When I am purchasing apple, what's the possibility that I am purchasing beer also? Okay, so possibilities like this: how many number of times you have purchased apple? 4 number of times. Out of 4 number of times, how many times you have purchased beer? 3 number of times. So 3 divided by 4, this is 3 out of 4, 75%. That's called as confidence. So when you purchase this and purchase that also, they are connected by the characteristic called as confidence. So confidence specifies how confident the rule is there in the previous cases. in previous observations. So in future also we'll have the prediction like the particular item will get purchased along with other item. Okay, if it is 100% confidence, it means that every time when first item has purchased, second item is also got purchased. This is what we call as the confidence. Along with that, the third is called as the lift. Lift is used like this says how likely item Y is purchased when item X is purchased, while controlling how popular the item Y is. Now in our table, the lift of apple and beer, apple to beer, is 1, which implies no association between the items. Okay, no association is there inside between these items. So the lift value is greater than 1 means item Y is likely to be bought if item X is bought, while the value is less than 1 means the item Y is unlikely to be bought if the item X is bought. Okay, so this popularity of these particular items are identified by the lift. Okay, so how likely item Y is purchased when item X is purchased, while controlling the popularity of item Y. So formula is given over here. Based on this formula, like support of both divided by support of first into support of second. With the help of this formula, we identify the lift of the given rule. Now so this is what the lift is calculated, and some examples I mentioned here. So in this way we are going to characterize these particular rules. Okay, along with this, two more are present. It's called a leverage. Leverage formula is given there. It's not used much. I'll just take an overview of it. Okay, so leverage value of 0 indicates the independence. Next is conviction. Conviction value means that the consequent is highly depending on the antecedent. Okay, consequent means if this, and antecedent means then that. Okay, so this is what the theoretical background we require to understand the association rule mining. Now to implement it, we need to add one extra package. Scikit-learn does not have any association rule mining algorithm, so we need to use some different algorithm like ML extend. So we need to install ML extend. So by using, you can use pip3 install ML extend, or by using your Anaconda also we can install the ML extends. Pandas, matplotlibs are already installed, and we require a CSV here to read the CSV file. Because the data is in non-structured format, it will be easy for us to use the CSV, this particular function, this particular package, to read this unformatted file in our code. Okay, so make sure that these packages are installed in your system, then only we'll go ahead to perform the operations. Okay, now let's see this is structured transaction, this is non-structured transaction. So structured transactions are easy to identify, but we'll focus on the non-structured transactions. This file just has shown to you groceries.csv, and this contains more than 9,800 entries present, by which we can find the association rules, how these items are connected together, and get your task done. So let's see. Before actually performing these operations, I just want to perform one small set of pre-processing techniques required over here. So let's go for a pre-processing technique here. So a simple pre-processing technique is required, which we have not seen in previous videos. This pre-processing is connected specially with the data set required for the association rule mining, and this pre-processing technique is called as transaction encoder. Let's get introduced to that, and then we'll go for using this particular data set ahead. Now in ML extend pre-processing package, we are having transaction encoder package or transaction encoder class saved in it. So I'm just reading that, and now on the slide this example was shown. Total 8 transactions are present: apple, beer, rice, chicken, apple, beer, rice, apple, beer, apple, bananas, milk, beer, rice, like all. Okay, this is not structured transaction, so I created a list of lists in which this data set is saved. Non-structured transactions are there. Now algorithm, the algorithm that we are going to use here, the algorithm name is Apriori algorithm. Apriori algorithm needs the data in structured format. Okay, it should be a perfect 2-dimensional format, but transactions are not in 2-dimensional format. So what we do, we have to encode this transaction in perfect 2-dimensional format, so that your data frame will be perfectly formed. So to do this one, we are going to perform this transaction encoding of it. So let's create the object of transaction encoder TE here, and after that TE dot fit transform the data set. So it will transform this data into transaction encoded format. See that. Are you getting it? What exactly the output is shown over here? The data is converted into perfect 2-dimensional array but what's the meaning of it? Let's understand it first and then go ahead. How many unique elements are present in it? So total 6 unique elements are there. Which one? Apple, beer, rice, chicken, milk and bananas. Correct. So these are the columns which are represented in alphabetical order for the respective one. See, first transaction. This is apple's column. Apple is taken? Yes. This is bananas column. Is taken here? No. This is beer's column. Taken? True. Okay. And this is chicken's column. Taken? Yeah. This is your what's this? Yes, milk column. This is false. Milk is not taken. And the last, according to alphabet, is rice. Taken here? Yes. So only 2 items are not present in this transaction. That is what we have, bananas and the milk. Remaining other are true. Correct? Yeah. So in this way, this is created. If you go to the last transaction, apple and banana. So only apple is true, banana is true, and remaining other are false. Got this? If you go to this transaction, okay, this transaction. So this is what we have. What's this? 5th one, milk. Yeah. So apple is not present, banana is not present, but remaining others are there. Chicken is present. Beer is present, chicken is present, milk is present, rice is present. See this one. So in this way, this transaction encoding has happened. So wherever the item is present, it has true, and where the item is not present, represented as false. Okay. And now in this transaction encoder, once you are fitting it, it contains a special item, a special variable in it. This is called as columns. So column names are this. Apple, the first column is apple, second column is banana, third column is beer, next column is chicken, this is milk, and this is rice. Now I will combine this and this together to form a data frame for me. So let's import that. Import, and let's create a data frame for me. See this, how it is formed. Transaction data is given, and to column names I'm using t.columns underscore. So all the column names are applicable, applied to this 2-dimensional array, 2-dimensional list, and the data frame is formed. Check out the data frame now. Perfect data frame is created. Now in transaction number 0, apple was present, banana was not present, beer is present, chicken is present, milk is not present, rice is present. Fine. So in this way, this data, non-structured data, we are transforming in the form of a structured data with the help of pre-processing technique called as transaction encoder. So especially for transaction, we have to convert non-structured transactions into a structured transaction. We'll be making use of transaction encoder by this particular mechanism. So why I'm showing this algorithm here? Because our data set is 9,000 rows are there. So 8 rows will be easy to understand. That's why I've shown that. So when you transform the data, it will be something very big data set generated out of it. That's why I've shown this one. Let's go for actual algorithms. So let's start. First of all, I'm importing CSV. So I'll show why CSV I'm importing there. Then pre-processing, I require the transaction encoder over here, which is also imported. And then from frequent patterns, in MLXten, I require the a priori. So a priori is the algorithm which is used to generate the association rules. So a priori algorithm is used, which is again present inside the sub package frequent patterns from the MLXten. And as usual, I require the pandas also. So what I have done, see, I have created one empty data set here, and by using with open. Okay, so this is file handling operation that we may have seen in Python. With open this file in reading mode as CSV file. So CSV file is the object of this particular file. Now CSV, so this we have imported. Inside this we have a function reader. Read this CSV file, okay, which contains a delimiter comma. Actually it's a default delimiter present here, delimiter comma, and reader is generated, and from that reader we are going to read the file line by line. So first line I am reading in row, generated, then second line in row, then next line, then next line, then next line, next line, in this way. And the transaction will be generated in the data set will be something like this, okay, in this way. First row, second row, third row, and they are generated and they are stored in this data set in a list of list format, okay. So that transaction I formed. So while using the pandas we can read it, but it will show the NaN values, not available values. So I just don't want that. I need to pre-process that and then convert it. So if I want to avoid that, I'll be making use of this CSV method. So all the data will be read in the form of list format, just as just shown over here. Data is huge, that's why I'm not showing it here. Now I got this data. Now let's do the transaction encoding. So T is equal to transaction encoder. Okay, it's created the object over here, and after that we are going to transform your data set in this particular format. And once the data is transformed, then we are converting the data into data frame format. Check it out, pd.data frame, and the data which is transformed, I'm going to have this data here, and these are the column names which I am providing. So columns equal to te.columns underscore, and a perfect data frame will be formed. And once the data frame is formed, check out the shape of it, data.shape. So number of transactions present in this data is 9835, and total number of items that's present are 169, because we have seen for every individual item a separate column is created. Okay, for every individual column we are going to have a separate column there. That's why 169 unique items are present in it, that we can say here. That's it, that's done. Now we are going to apply the a priori algorithm. Now a priori algorithm, so still this if you have seen, again check it out. Now let's go for a priori algorithm here. Now a priori algorithm is just we are imported, and we are going to apply this. This data is structured format data which is required by a priori algorithm is passed here. Now we have to generate the frequent items. So based on their support, the item frequency is identified by a priori algorithm. So what's the minimum support you provide? For example, I provide the minimum support as 0.1% here. Okay, minimum support means how popular the item is in the data set. So only that items which are 1% popular, only that are taken. Okay, and use column names, yes, 2. So column names are the name of the item that you have to use it there, and frequent items is formed. Now frequent items dot head, total frequent items and frequency of that items will be shown like this. See, if I see the head for 5 items, okay, so 0.008 is the support of this, 0.003 UTH milk, HT milk, then abrasive cleaner, RF sweetener, baking powder, like all. Many items are possible, and their frequency will be shown after this. And now we are going to apply the association rules algorithm after the frequencies identified by using a priori algorithms. How to find it? So from ML extend frequent items, I am importing association rules function. Association rules function is used to generate the rules from the frequent items. How to do this one? So rules equal to association rules, give the first parameter as frequent items, second parameter is metrics. Metrics means I want to generate the rules. Which rules? The rules which contains minimum confidence as 0.8, means minimum confidence at 80%, means the item has purchased, first item has purchased, then second item is also purchased, and their connectivity in the previous data set should be minimum 80%. Okay, that's why I am going to perform here, find the rules, and once you apply this confidence, this amount of confidence minimum threshold as 0.8, the rules will be generated, and that will be stored in the rules. If you see the length of rules for that, total 409 rules are there which contains 0.80 confidence. Okay, not only the confidence, but you can apply the other metric also. I want the lift. Okay, I want this frequent item, generate the rules. Okay, rules 1 like which contain the metric as lift, and that lift should be minimum 10. Minimum value for the lift should be 10. So the rules will be generated. So I will have the rules 1 here generated, and if you see the length of these rules are 1765. So total 1764 rules are there who's having lift minimum 10. Okay, so likewise confidence, support and lift, these 3 different parameters we can apply to generate the rules. So rules will be generated, we can have 1764 rules. Okay, so before visualizing the rules, I'll just show you how different parameters that we can apply over there. Now let's see. Okay, so if you print the rules, all 409 here and 1764 rules will be generated here. Now to this particular rules which are generated here, I want to apply one more parameter there. So when you print the rules, just check the rules how they are generated. In this way the rules are generated. So it contains antecedent, consequence, antecedent, consequent, and antecedent support, consequent support, support, confidence, lift, leverage and conviction. Okay, so what's the meaning of this? So if you are purchasing this called as antecedent, then you are most likely purchasing the consequent also. means if you are purchasing cereals and curd, you are purchasing whole milk also. Okay, so support of these two together, means popularity of these two together is this. Okay, and the support of consequent is this, means 25% time in the whole transaction whole milk has occurred. Then support, okay, support of all three is this. Okay, support of all three that are coming together is this. And confidence of this rule means when I am purchasing cereal and curds, along with that I have purchased whole milk also for 90% times. That is what we call as confidence, and based on that we have generated the rules. Okay, now these rules will be shown when you generate the rules over here and you print that. Now I want to apply, I want one more column present over there, the length of the rules. Okay, length of the rules. Length means antecedent length, means on this side only two antecedent, or I just want the length of all, means how many antecedents are present that I want to apply extra column to. This is extra column to the data set I can apply by this method. Rules of antecedent length equal to rules of antecedents. Antecedent means this side, if this dot apply lambda of x len of x. What it does, for every antecedents line it will find the length of it and attach that particular length to this column, antecedent length. A new column will be generated connected to the rules which will contain total number of antecedent, that is if these items are available. So by this we apply that. Apply method will be applied to all the rows of this particular rules data frame. This way we apply that. So when you print this, we just can have something like this. Antecedent length is 2 presented over here, but maybe 2, 3, 4 like that all antecedent length will be generated. If you see this here, 2 antecedents are there and one extra column is attached to it with antecedent length. Okay, now from these rules I want to now apply many more criteria there. Many more criteria means, for example, new rules I want to form, and now in these rules I want antecedent length, I mean total number of items on the left hand side should be less than or equal to 3. Okay, less than or equal to 3, and confidence of them should be greater than or equal to 99. Okay, confidence should be above 90 and lift should be above 2.0. So 3 different parameters or conditions I combined here, and based on that extraction of rule is possible. That rules we can store in this end rules variable. If you print the end rules, again the rules which follows all of these criteria will be printed. Okay, so something like this. Okay, maybe the number of rules will be there, some rules are present which are following all of these 3 criteria will be generated. Okay, so in this way you can do it. Now a few more operations, like I want what I want on consequent side, means I want then that this part as whole milk only, so I can use this one. Rules of consequence is equal to whole milk. Only that rules are extracted. Okay, I can extract only the consequence where whole milk is available, that rules, and store it in. Or I want to extract only the rules which contain antecedent at cereals and curd. Okay, like this end rules are there, and if you print that end rules I'll get something like this. Check it out. So this rule I formed from this consequent side I'm having whole milk, okay, and antecedent side only I have cereals and curd. Okay, so when I form this rule, only one rule is there which is having this and this connected, which is having this thing also, where antecedent length is less than 3, confidence is 90% above, and lift is above 2. Okay, so this is how conditional extraction of the data, condition extraction of the rule will be done on these association rules over here by applying such kind of the methods here. Okay, so you can try that and check out the output of this. Now this is very big line, so 1 2 3 4 5 6 7 8 9 and 10. So 10 columns are present over here. I don't want all of these 10 columns, I want only the 3 columns of all. Which one? If this, that is antecedent, then that is consequent, and confidence. What's the confidence of it? That's what I want from the rules. So I'll use this method, which is the similar method that we have seen from extracting the columns from pandas. So same way I am extracting these rules, which is called as end rules, and then if you print the first 5 rules, So you can see this one, first 5 rules, if this then that and their confidence. Okay, so this is how we can extract exact rules based on these consequent, antecedents and the confidence of them. So this is generally we require. We don't require the remaining characteristics for the respective rule generated by using this a priori algorithm here. If you see the length of rules, that is what we have, 409. Okay, so similar to that, if I want to extract only the confidence greater than 90. Okay, so here I am having 80 above confidence almost everywhere. From this 409 I require 130 rules only, means the rules which are having confidence greater than 0.9. Okay, so I can extract that with this Boolean filtering mechanism. Wherever the confidence is above 0.9, only they are extracted and they are stored in end rules. And you can see how many end rules are there, 130. Okay, which are having confidence above 90%. And finally, last, I want to sort all the rules by some criteria. So there is a method in pandas package by which we can sort all the rules by one of the columns. So the column which I have chosen here is the confidence. Let's see. and rules dot sort values by confidence. So by confidence I am sorting all the rules in ascending order, descending order, that is highest confidence will be on top, descending I am making false over here. And if you see the head of these rules, check it out. So if this then that and their confidence is 100%, see this. Okay, 100% confidence. You can check the length of antecedent 4 3. This is which I have attached already with the help of lambda apply function there. And confidence of top 5 rules generated here is 100%, 100 100 100 everywhere. Okay, so based on that we form these rules and then they are printed. So sorting of rule will be done. After the sorting is completed, we can save these rules inside the file. So total rules are 130, and to save the rules inside the file we are having the function called as toCSV that we already seen in pre-processing. So nrules.toCSV, all the rules I can save inside a file whose name I have given as rules.csv, and all these rules will be saved there. So this is how a priori algorithm is to generate the rules, and you can perform various operations on that rules. You can access or extract the rules as per your criteria also. Okay, so let's see, this file is saved here. Where is that? And rules.save, and okay, it's not saved here. Okay, but you can check it how exactly the output is generated for these end rules, and it's there, antecedent, consequence and the support, the confidence, that will be saved in a CSV file format, and that we can use to perform further operations. So this connectivity of different kind of the data is possible with the help of the association rule mining. We can perform this operation of association rule mining technique to find the associations rules among different kind of the data items at various positions. Just like cross selling, we can make use of it in product placement, we can make use of in affinity proportion, fraud detection, customer behavior identification. So these are the some of the applications where this data mining algorithm of association rule mining can be effectively used. I've given the diagram, so I've given the program with you, data set is also given to you, and basically MLXtend I have used here. So MLXtend's official website is this, from where various algorithms of MLXtend can also be seen. We can download it, you can install it, and you can practice this on different kind of the data. So along with this I have given 3 transaction files. You just can check these transactions are working on these files or not, and what sort of results are generated out of it. So this very interesting algorithm of unsupervised machine learning that we have seen to find the patterns or to find the rules of if this then that. Just try it. Have a nice day. Thank you.